Okay, as you can see here, now, acid name. So first of all, we have to understand what an acid is and how we should recognize it, right? So what we do is we use something called the Arrhenius definition of an acid. What does that mean? It means it has a hydrogen or a proton donor at the front. Why do we call it a proton? Because the hydrogen's got a +1 charge when it loses an electron. Thus, that just leaves it with 1 proton, no neutrons, no electrons. So it's just a proton. That's why we call it a proton donor. So what ends up happening here is you have hydrogen, and then you have something that is negatively charged right here, like we name 1, 2, 3, etc. And so there are some rules that apply to this hydrogen, right? Being here with this anion, we call it an acid. So there are 3 rules. The first of which is this one. If the anion ends IDE. So for example, if this was, Cl, right? That would be chlorine, so it become chloride. Well, we end up changing it. And here's what ends up happening. This would be the chloride ion. So with an anion ending IDE, we give the name of hydro. We give the base of the name and the ending of ic in the word acid. So for example, HCl ends up being hydro chlor, because that's the base of chloride, chlor, ic in the word acid. There's a couple places where we get a little bit trickier, but that's pretty much the gist of it. Let's say though we take hydrogen and sulfur and we put it together. Well, sulfur carries a -2 charge. Therefore, +1 we need 2 hydrogens, H2S. Well, when you go to name this, right, you just look at the anion part, the negatively charged part. So when you look at this, you see sulfur. Sulfur becomes sulfide, right, as an ion. So therefore, that ends IDE. So hydro plus the base of the word. The basis of this one is sulf. Right, we drop it. But in order to help ourselves say it, we actually put the UR back and then ic. So with sulfur, it becomes hydrosulfuric acid. It's kind of a funky thing, but we leave it. The other one it does that with is H3P. Okay? So first of all, it's an acid because of the presence of a proton, 3 of them at the beginning. You cover it up, you look at the P, right? Phosphorus, well, that becomes phosphide, right? So, ide would give this hydro plus base plus ic name. So it's hydro plus the base. Well, you would think it would just be phos and then ic, right? But we add a little name here too. We name it phos, we have this little OR. So it's hydrophosphoric acid. You'll see that on the other ways too. We always have this little UR when there's sulfur and this little OR when we do phosphoric acid. Okay? Okay, well, let's say the anion doesn't end I. Let's say the anion ends ite now. So if something like HCl, you see HClO2, which we're learning is -1 charge, and that's the chlorite ion. Well, what do? You do this. You just give the base of the name plus the ending of OUS in the word acid. This is a very funky one. So this is chlorite. Therefore, this becomes chlor, base of the word, us, OUS, in the word acid. So, by the way, that's this one. Let's do another one. How about phosphite? So the H3PO3. Why? Because phosphite carries a -3 charge, +1, +1, +1. That's why it's H3PO3. So if you were to cover up the H, and just look at PO3, right? You would see that this is phosphite. Let's put it back. But you would say, okay, it ends ite. We get the base plus OUS in the word acid. So, phos gets that weird little OR thing we just talked about. And then OUS, acid. Okay. Yeah, and that's ites. Let's do the eights real quick and then we'll go from there. Okay, so now let's say it's not chlorite, it's now chlor-8. So it's HClO3. So it ends A-T-E, 8 now. What do? Well, base plus the ending of ic in the word acid. Okay? So here we go. Like H2SO4. So hydrogen, the reason there's two of them, plus 2, right? Plus 1 for the negative 2 here of sulfate. So when we look at this, we say, okay, we cover this up. We have SO4 minus 2, which is sulfate ion. So this becomes the base plus ic plus acid. So this becomes sulfa with that little UR thing, because that always gets added in. The ending of ic and the word acid. How about this one up here? HClO3. Well, it's plus 1 minus 1, so it's written right. When we look at ClO3, it's chlor-8, therefore it's base plus ic, acid. So this becomes chlor, the base, the ending of ic, and the word acid. Chloric acid. Or how about this one? You ready? Here's an interesting one. HCH2COOH. Well, you cover up the H and you get left with what you know as the acetate ion, right? Well, it ends 8, acetate. So we look at that, we say base plus ic plus the word acid. So this becomes acetic acid. And let's do one more. Carbonate. So H2CO3. Cover it up, that's carbonate, CO3. Therefore, it's an 8, base plus ic plus acid. So this becomes carbon. We drop the 8, ic, acid. Now, let me show you the one weird exception. Okay? And it goes all the way back to the beginning. So, one weird exception. Most of your polyatomics end either ite or ate, but you have one kind of oddball, and it's this one, HCN. Well, hydrogen tells you it's an acid. CN is cyanide, right? So then it ends ide. So therefore, ides are hydro plus the base, cyan. It now becomes ic. And the word acid, hydrocyanic acid.